So good morning again. So let's get started. And yeah, so what's the problem with the command line arguments? So we looked at command line arguments. I just want you to understand at this level that so this is GCC name sort 4.c. So GCC name sort 4.c dot a dot out names dot text. So here, this is what is called as a command line argument. This is what is called as a command line argument. So if you see the function main, it has two parameters, int argc, char star, excuse me. Excuse me. So here argc, what will argc tell? Argc tell the number of arguments. But the important thing is, even this dot slash a dot out is counted as an argument. So if I am right, so we can just see that if argc value, it will be equal to thank you. Argc value will be equal to 2. And arg star v of arg star v char star no, this is an array of character pointers, and so this will point to a string. This will point to a string which contains this. This will point to a string which contains names.text, followed by 0. If there is one more argument, it would come up here. That's all. So if you want to check this one a little bit more, so we can do one thing. So GCC minus G names sort 4.c. So gdb a dot out and break main. So now I'm saying without passing any command line arguments, I'm just saying run. Now you can see the argc value. What is the argc value here? It is 1. You can see that main is being passed parameters and the argc value is 1. I didn't pass any parameter, the command line argument. But and then if you try to print, but since argc, but even then argc is equal to 1 because rv of 0, if you do, yeah, so this is what rv of 0 is. So let's say if I run what is this, run with names.text as the parameter, and you can see now argc value is equal to 2. Print argc is equal to print argc, it is 2. Print argv of 0, it is this. Argv of 1, it is names.text. Let's say if I run it with no, like for example, names1.text, names2.text, names3.text, the program will not be able to will not be able to process. Our program ignores these names2, names3.text, all those things. But I just wanted to illustrate a point using GDB. So that's the reason we can see print argc is equal to 4. And then this is argv of 1, argv of 2. What will happen if I do argv of 4? Maybe it may crash. Yeah, so argv of 4, it's not there. So are you with me here? You all understood? Okay, so good. So now what we will do is we will take this program and modify this program so that what do we do here? So we would like to, so here we have sort names and all these things, print names, sort. So we call read names, sort names, print names. So we also would like to write names function. What will write names function do? It will write the names into a file. So let's say write names. So let's do this thing. Yeah, file star fp out, and also this is for and then we will have char output file name. Let me use f name as a so at this point what do we do? So we create a, so here, so one super bad thing that I did through all this is I didn't write even a single comment in my code. So don't, I'm just being lazy. I should have done that actually. No, they don't point anywhere in the virtual memory, Anish, fp out. So output f name, and here arg b of 1. So string cat is another function, output f name. So do you see what we are trying to do on line number 100 and 101? Or you are able to see what we are doing on line number 100 and 101? We are copying the source file name into some string, and then we are appending the extension dot sorted to it. So we are just adding dot sorted to that file name. Are you all with me on line number 100 and 101? Yeah, it becomes names.text.sorted. Okay, so we are copying the string. So here we are on line number 100. Let's say if the input string is names.text, we are copying that string into this string, into this character array. So after this line, it will be output f name, it will be pointing to the string names.text. And then strcat is string concatenation. That is, this string will be added to this. So after the line 101, so it will become names.text.sorted. This is what I'm thinking it will happen. String cat function, I'm thinking it will happen. That's what it does. No, it is just a convention. So what we are doing is we are just trying to, yeah, let's follow my line of thinking, and then we will see what happens. Okay, f open. You want to output yeah, output f name. Yeah, output f name, and then we want to write it in the write mode. So we want to write the sorted file in the in the file no names.text.sorted. So that's what, so we opened a file. So here on line 92, we opened a file in a read mode, and on line 103, we opened a file in write mode. All right. Yeah, it's a file name extension, but it's not a standard file name extension. That's true. And then we want to do this right name. Names file pointer. No, it does. We don't need a file to exist to be opened in write mode. So we are calling this function write name. Let's write this thing here. So void write name. Actually, let me do one thing. So char star star names, number of names, file star. See, actually, let's do one fun thing. Let's do this. No. So print names, I will do file star fp. I will here, right here, and then I will say fprintf fp, and then I will remove this actually. Let me change my idea. Are you with me on line number 46? Can you pay attention to what happens, what is happening? W means write mode. On line 46, to the print names function, we added this file star fp, and then we changed the printf to fprintf. Are you all with me on this change? Yes or no? So now, yeah, so now what we do is we do print names here. I will do two things. So print names fp out. It will write it to the file. And if I do print names std out, it will be no fp. It's not, you're not printing to the input file. We are printing to the file on line number 104. There is we are opening a new file and we would like to write it. Are you with me on what is happening on line 115 and line 117? What does print names function do? Print names function, we have modified it to say that we would like to write it to a file stream pointed to by the pointer fp. Yeah, that's true. Fprintf with std out is just regular printf. That's true. Line 46, instead of printf, we have fprintf, which prints the stuff to a output stream. Line 49. And then, so on line 15, we are printing it to the screen, and on line 117, we are writing stuff to a file stream, file output stream. Let's compile this program and see what happens. So now there is, it got printed onto the screen, but if you do ls, you will see this file names.txt.sorted. And then if you see that names.txt.sorted, it has all the stuff that the names in the sorted order. Are you all with me here? This is my nice, small, simple program. Doing all right? Good. So now let's, can you comment out line 1? Yeah. So if I comment out line, then nothing gets printed on this. those the list will not be printed onto the screen. Great. Yeah, we are using fscanf and fprintf. That's true. So let's say when you have all these things, usually, like we have a, what do I say? On line 117. Yeah, so we are all good here. I'm just thinking about something else. So yeah, so let's say after you sort, you want to do something else, right? Or you want to free the memory. So here, if you see at the end of in so far, it's just think of file star as a file pointer. Don't read too much into it. That's all I would say. Let's say, so in this particular case, one thing about this particular thing is we are not freeing memory at all, because when the program exits, because of the particular way in which the program requirement is there, you allocate memory, and then you kind of sort the data, and then you are exiting from the memory. So we are not having explicit we are not freeing memory to heap at all. But let's say after we are doing this in a bigger application, and then so at the end of the day, after you are done, you want to free the memory that is allocated. You want to free the memory that is allocated. Okay, free names. So if you want to free the memory that is allocated, we can use this thing free. We have to use the free library call and pass it the point. So now if you see, so everything still works, but here free doesn't have uh, much impact, because anyway we are exiting after the free is done. So I have a question for you. Let's say after this, let's say there is a bigger, lot more code is there down the lane, more program logic down the lane here. Then what happens here? So like this, there is more program logic here, and on line 119 we just did free names. So are we in a good shape when we start doing further processing from line 121? Free makes the memory available for further logic. You cannot free names and then after that try to access it. So is there a problem in yeah, the previous data is deleted. Yeah, deleted means we don't know, guarantees are given. Yeah, so Shashwat and Shubh has got this nice thing. So that's what I'm looking for. If you see, our names is an array of pointers. Our names is an array of character pointers, and each of them is pointing to a heap. So when we do a free, so names, this is our names, and names contains the base address of this. When we do free names, then what happens is this whole memory, let me use a different color here, this whole memory, this gets released. But what happens to all these chunks of memory that are there? They are still there in the heap. And on the top of that, when we release the names, what happens is the memory that is allocated to these individual strings, they are still there and they are not accessible, and there is no way for us to free them because the pointers to those memory locations is lost. So this is what is called as a memory leak. So this is what is called as a memory leak. Memory. Are you all with me here? Do you understand the problem? See, when we free names here on line 119, we are freeing the memory associated with the array of character pointers. This whole thing is, this whole array is freed. But the problem is each of the elements in this array, they are pointing to a chunk of, to a string in the heap. When this when this names array gets released, these are like, they are there in the memory, but no one is pointing to them, and there is no way for us to free it, and it's a problem. So what we have to do is, the pointers vanished, and no the but so they stay in the memory, and that becomes an issue because the whole memory, it becomes what is called as a memory leak. So if you want to free the memory, the right way to do it, what is the right way to free the memory is, you should do for I is equal to 0, I less than number of names plus I. Someone posted this code actually in the box, free names of I, and then after that, after you do all of this, then you free names. This is the right way to do to free this whole data structure. So by doing this, you tell mloc library that all this memory is available and it can be reused for some other purpose. How many of you are with me on this problem, the problem of memory leak? And so this is how, it's a very nice thing. So these things you should know, nice, important, nice ideas. So all this code. No, yes, that's true. When we exit the program, the memory associated with all the program will be lost. But when we are writing huge software, let's say you are working on, you are using Chrome, right? If Chrome browser, once you open the Chrome browser, maybe it will be there, no, forever. No, forever means at least a week, it may be just like that. So if there is a memory leak in the Chrome browser, then what happens is, it just keeps consuming the memory of your system, and it kind of, the whole thing gets sunk, your whole system sinks. So because of that, no, so those are the applications where, or let's say if there is a server, let's say, there's a server which hosts no JEE results or whatever exam results, and there is a bug in the program there, and there is a memory leak. So as time progresses, no, more and more memory gets consumed, and there is no way to reclaim that memory. Uh, so and your the server crashes after some time. You can have a no server with size 200 GB RAM, but within a short period of time, you will no kind of sink the whole memory. No, so if free doesn't clear, but once it is freed, Pramod, so it will be, when you do some other MLOC, it could be accessed by that. It will be allocated to that chunk of, to that MLOC request. Once, when you do free, it goes to the free pool, and the MLOC request down the lane can get memory from this free pool and give it to you. right? So there are a few questions. I will hold those questions. Yeah. So yeah. So this is the right way to do this thing. So now let me. Yesterday I was trying to see how we can use valgrind to. I didn't use valgrind quite a bit before, but nevertheless, yeah, quick start. So here, let's take this program. So there are valgrind can do, it's a bigger tool. And among the many things it does, one thing it does is finding memory leaks. Okay, this is a program. memleak.c. So if you see this program, what is happening? Can you please pay attention to this program? There are two problems in this program. So can you pay attention here? What are the two problems in this program? So first of all, like you are allocating memory in the function f, and when you come out of the function f, you are losing the pointer to that chunk of memory. So, and that is one problem. So the second problem is x is we are accessing a memory location in the heap which is not allocated. Yeah, so you are not freeing x, and you are accessing index 10, which is not allowed. The maximum index that is allocated is that you can access is x of 9. No, this is just to give an example, Aditya. In this particular case, this program is useless for all practical purposes, right? The point here is you allocated a chunk of memory x and you are not freeing it. So, and you are coming out of the function f. When you come out of the function f, you don't even have access to that uh, to the base pointer of that memory chunk. So let's compile this code and see what happens. GCC -g memleak.c and valgrind /. So if you do a valgrind /a.out, you can see there are a couple of things. Number one, it says in function main and in function f on line number 6, there is an invalid write of size 4. On line number 6, there is an invalid. Please pay attention. So I think you have your questions. We will hold them. So please pay attention. So on line number 6, it says this part. First, look at this first problem. It says main called f on line number 11, and in the function f on line number 6, there is an invalid write of size 4. So there is an invalid write of size 4 because you are trying to write an integer to a memory location which you are not supposed to write. This is the first error. The second error is, if you see, definitely lost. Yeah. So memory leak summary, definitely lost. 40 bytes of memory is lost. 40 bytes of memory is lost. So why is that 40 bytes of memory is lost? We allocated 40 bytes of memory on line number 5, and size of an integer is 4. 40 bytes is lost, and we are not able to access it because once we are out of f, because the pointer to it is gone. Are you with me on these two errors? How you can use valgrind? That's true. All the memory is freed at the end of the program execution. In order to make it very, very apparent to the valgrind, so like for example, maybe if you keep it in main, so it may not quite catch it. Okay. So I want you to understand this is a toy program constructed to illustrate a problem, right? Are you with me? This is a toy program. In order to illustrate that the point, we put no, we did an malloc in the function f, so on and so forth. But let's say here, let's say if you do only this, will valgrind be able to catch it? I don't know. I didn't try it. Is there a memory leak in this one? In this program? Is there a memory leak? There is a memory leak, right? So there is a memory leak, but will valgrind be able to catch it or not? We don't know. Let's try to see. Maybe it may think there is no memory leak because after this, no, it's all the program is terminating. I don't know. I didn't try it. So let's try to do this. So valgrind. So in this particular case, it is saying there are no, all heap blocks were free, no leaks are possible. So it is not able to catch this. So it is not able to catch this. So maybe what should we do? Should we, in order to make this do less than name sort? No, we don't need. Oh, sorry, we don't need this one actually. Yeah. Yeah. Maybe let's do. So now we got it. Yeah. So now so now it says 220 bytes in definitely lost, 220 bytes in 31 blocks. Does it make sense? Why is it 31? 31 blocks. Where are these 31 blocks coming from? There are 31 names. Yes. See, there are 31 strings. So those strings memory, we are not freeing memory. So it says 220 bytes in 31 blocks is getting lost. Are you happy with the valgrind tool? I'm happy at least. So yeah, so these tools you should use to see what is happening, especially in data structures course, when you are working um, with data structures, linked lists, or very complex tree data structures. You should it will help you. And also one more thing, if you see, valgrind can do lot more stuff. Like for example, yesterday I was exploring, there are multiple tools under the valgrind which come under the valgrind umbrella. So cache grind, call grind, and all these things. So Gaurav, that is from the previous program, those 40 blocks. There are no 40 blocks. That is one block of, Gaurav has this nice question. I want to clarify this once. Here, there is only one block of 40 bytes, Gaurav. Only one block of 40 bytes on this in this program. There are no 40 blocks. From malloc perspective, you are asking for 40 bytes of data in one block. Are you with me? I hope you understood the point. No, in the name sort program, there are 31 names. There are 31 names and no, at this point, when after line 123, at some point in the program, uh, there's a memory leak happening. Block means a continuous array or byte of memory. So I want you to, anyway, I want you to, you should think about it again one more time. So man valgrind this, and if you see, there are many tools available. One tool specifically I would like you to experiment with a bit is maybe cache grind or call grind, for example. So let's say I will say man minus tool is equal to cache grind. So in your later on, you will learn that in your system, there are many, there's a cache hierarchy and all, and the performance of your program depends upon the number of instructions executed, the L1 cache misses, L2 cache misses, so on and so forth. So valgrind will be able to give this information. And there is something called as a K-cache grind, using which you can visually see all this stuff. So then there is call grind. Okay, let's not worry about it. So yeah, that's all about memory leaks. I hope you are all with me on this in today's lecture. You're all good. You're all doing good. I would like to stop here because yeah. So the next topic I would like to do is multi-file programming and make files. I'll take one lecture on that. After that, 3 lectures will be on data structures, linked lists, and stuff like that. Before I answer, I just want to give this summarize. Number 1, so this is all about memory leaks. In one more class, I will talk about makefiles and multi-file programs. And then we will have 3 lectures on, what do I say? On data structures, linked lists and trees. That's what we will. So Kush, I'm trying to tell you, I gave you an example that in this program, this memory leak is not a problem. In this program, memory leak is not a problem, but there are many places where memory leak is a problem, because the example that I gave you is a Chrome browser. If there's a memory leak in the Chrome browser, or if there is a memory leak in your video, let's say you in the Netflix player on which is running on your TV, if there is a memory leak, no, every few minutes it will crash. No, but we didn't do an malloc. We did an malloc only for 31 names, no, not for 40 names. But only 31 mallocs. Not structs right now. I will look at the structs later. Okay, because it's better to start fresh. That's true. Number of malloc calls is equal to number of blocks created. Chinmay is interested about exam. Let me stop the recording. That's true. Mugundan, this is, yeah, let's do the final thing, which, yeah, so let's do this, which is what Mugundan wants to do. You are all the time interested in, you guys in crashing programs rather than building programs. What happens here? While one, does it work? Yeah, it should work now. What happens? You tried all this already. What happened? But there is an error. Why is it showing an error? A dependent statement. Oh, okay. This is because of this. Okay. May not be. Why bother? I'll just make this into int star x. Make it okay. Let's compile this program. GCC memleak.c, GCC memleak.c -o memleak. Okay, 11:15. I should stop. So this is my current memory profile. And let me run this program and see what happens. Dot memleak. See how my memory is increasing. 15 GB, 17 GB, 18 GB, 20 GB. I think I'm 25 GB. After it comes to 40 GB, I will kill it. $40 GB. Okay. Either the system will go slow, I'm killing it. So you see this, you see it, no? Is it fun? Isn't it fun? So now it again came back to 7.8 GB. So if you do it on your machine, it will crash much more faster. So now it's 7.8 GB back to normal after killing that program. Add one more line to it. What line should I add, Vivek? But now, I have a doubt though whether valgrind will be able to catch this. What will valgrind do if I ask it to check this one? GCC memleak. Okay, I should stop in 2 minutes, otherwise I'll get a message from academic office that I'm overshooting time. So yeah, so now valgrind also, I don't know how valgrind can do this. So if I do Control C, valgrind is saying, no, it's a heap summary. Okay. I have to kill valgrind because there is an infinite loop, but valgrind says no, that there is definitely lost this many blocks of memory. Valgrind says. Cool. So I think with this we should uh, conclude today's lecture. I hope you understood what's today's you're all, I hope you understood the last exercise. It's a fun exercise. I hope you understood it. And so you can understand, no, like in real systems, when there is a memory leak, why it's a serious problem. Valgrind continuously, see, valgrind is an interpreter which, instead of running it on the processor, it interprets the instructions of the processor. So it continuously monitors the memory leaks. Kush, that is the answer to you. Because of that, since valgrind is running it, it is continuously, it also got into an infinite loop. So because of that, we have to terminate valgrind. And when we terminated valgrind, so valgrind gave the statistics at the point it got, we terminated it. This is the answer to the Kush's question, which is bothering him from the beginning. So it does more clever things, valgrind, but pretty much it interprets the program. It's not exactly interpretation. Actually, it kind of provide hooks, and it will do a few interesting things. Let's not get into the details of valgrind. It's a very sophisticated program. So we'll get to know about valgrinds maybe sometime down the line in your future. But for now, this is what it is. You can use it as a tool. No, time now is 11:20. Sorry, guys, I have to conclude. I heard you have a class at 11:30. So we should conclude.